Hello everybody, welcome to my channel. Well, in our previous video we were talking about atomic orbitals and about electronic configurations. So this video is continuation of the previous video, and today we will talk about quantum numbers. And here you can see the book from which I used most of the material in my video. Okay, let's imagine an atom. We know that atom consists of the nucleus and electrons that are rotating around the nucleus. Let's imagine that this atom has one energetic level and it has electrons. We know that actually atoms can have more energetic levels, different orbitals. So when there are more energetic levels, more orbitals, atoms become larger and larger. Well, so if we talk about quantum numbers, so let's start with the principal quantum number, n small. So n has values which are more or equal to 1, 2, 3, 4, etc. So it has integer numbers. Well, it characterizes a shell. So n shows the number of shells. So when n is high, it means that electron in the atom had higher energy, because on different energetic levels, electrons have different energies. So if you see in the picture, in the table, we see each value of n characterizes one shell. For example, if n is 1, this is K shell, and 2, this is L shell, 3 is M, etc. If we have a look at the periodic table, we see that there are periods and groups. So the number of period shows the number of energetic levels. For example, if we take hydrogen or helium, which are situated in the first period, we can say that they have one energetic level. So N for these two atoms will be 1. If we take lithium, beryllium, or other elements of the second period, such as boron, carbon, nitrogen, oxygen, fluorine, or neon, they will have 2 energetic levels. So N for them will be equal to 2, etc. So the number of period of an element shows the number of its energetic levels, so it corresponds to N value. And the next one is the angular momentum quantum number. The angular momentum quantum number is also sometimes called an orbital quantum number, because it showed the subshell and the shape of an orbital. We say that we have different shapes of orbitals, like S, P, D, F, etc. We will be focused on S, P, D, F. So each of them had its own shape. We discussed these orbitals more detailed in the previous video. You can see the link for the previous video in the description of the two for this video. Okay, so values of L can be from 0 to n-1. This is the range. It can vary. So it defines the shape of orbital and characterizes a subshell. Pay attention on this table. You see values of L. If L is 0, it will be S subshell, so which consists of only S orbitals. It will be spherical. If you remember the shapes of the orbitals, like P had looks like the 8, S had a spherical shell, D looks like a flower, etc., etc. Well, if value of L is 0, it will be S subshell, 1 is P, 2 is D, etc. From this table, we can see it clearly. So, again, let's remember the principal quantum number characterized as shell, angular momentum or orbital quantum number, L, characterized as subshell. Let's now continue. The next one is the magnetic quantum number, ML. It characterizes an orbital, and it determines the spatial orientation of an orbital, because we know molecules are not on the plane. They are in 3D area. So they can be, it would draw 3D axis, spatial axis like X, Y, and Z. We know that p orbitals, they can be in the axis of X, Y, and Z. So magnetic quantum number shows which of them it is. And it varies from minus L to L. The values of ML can be between minus L till L. Let's see more detailed to understand it. Look, let's for example take 2p subshell. We have 1s2, 2s2, 2p6. We discussed it in the previous lesson. Well, and let's find the quantum numbers for this one. We know that n can be more or equal to 1. It's the second energetic level because it's 2p. Energetic level is 2, so principal quantum number n will be equal to. What about L? We said that L can be between 0 and 1. It can vary from 0 to 1. Why 1? Because it's actually n minus 1. In our case, n is 2, so L will be 1, either 0 or 1. But which of them? Let's again remember this table. You see? So we have P, 2P subshell. If this is P subshell, value of L will be 1. So L equals 1. Okay? So what about ML? Now we know that ML can be between minus L to L. Okay, so it can be minus 1, 0, and 1. Let's now figure out which value of it. How can we define if it's minus 1, 0, or 1? We say that P subshell consists of 3 orbitals. Each of them has one value of ML. Look at this picture. This one, minus 1, 0, and 1. You see? So now it depends on which orbital we are talking about. If we are talking generally about 2p subshell, so ML value might have three, like ML might have 3 values. But if we mean, let's suppose we mean this orbital exactly. We are interested in the middle orbital. In this case, we will say that ML will be 0. Depending on which orbital you take, you'll find the value of ML. If the orbital is not defined and you don't know which orbital is intended to set in exactly, in this case, you say that ML value might vary from minus 1 to 1. In our case, it will be 0 because we are interested in this orbital. So let's now continue. Well, we have figured out with 3 quantum numbers, principal, angular, and magnetic quantum numbers. And now let's talk about spin quantum number, the electron quantum number or the spin quantum number. And this quantum number characterizes an electron. Okay, so we said that n can be from 1 and more. L varies in the range of 0 till n minus 1. ML might have values from minus L until L. And MS might have values. It might have only 2 values, plus or minus 1 the second. It characterizes an electron. So let's draw an orbital, and we said that on one orbital we might have only 2 electrons. We discussed it in our previous video. So that can be 2 electrons with different spins, like this and like this. Okay, so if we again look at our 2p subshell, and if we are, for example, interested in the medium, in the orbital with ML value 0, let's have a look at our electron. There are 2 electrons. So I colored them. One is blue, the other one is green. Let's imagine that we are interested in the green electron, which is marked here green. So its spin number will be minus 1 the second. the other one will be plus 1 the second. So this charge, plus or minus, and it shows the spin, like if one electron on the orbital has plus 1 the second quantum number, like magnetic spin quantum number, the other one will be minus 1 the second because they have opposite spins. Okay, let's now practice a bit. Look at the picture. So here you have the values of some of the quantum numbers, and you have to find the possible values of the missing one. Well, pause the video and try by yourself. After that, so you can restart the video and check your answers. Okay, now let's have a look. We said that L value can vary from 0 to n minus 1. So it can be 0 or it can be 1. Yes, because 2 minus 1 is 1, so L here can be 0 to 1. Let's have a look at ML value. We know that ML might have values from minus L to L. If L is 0, ML will be only 0, but we see our ML is minus 1. This means that L cannot be 0, it can be 1. If L is 1, so ML from minus L to L will be from minus 1 to 1. In this case, ML might be minus 1, 0, or 1. So L value here will be 1. Let's go to the next exercise. Next row. So N is 2. Again, we say L can be from 0 to 1. We see that ML is 0. If ML is 0, it means L might have both the meaning. If L is 0, ML will be 0. If L is 1, ML can be minus 1, 0, or 1. So both variants are possible. L here can be 0 or 1. Let's now have a look at the next row. N is 3. So L is 2. ML might vary from minus 2 up to 2. Minus 2, minus 1, 0, 1, and 2. The next one. Okay. For N is 5, L is 0. If L is 0, ML is always 0. And the last one, L is 1, ML is 1. L, we said that can be 0 or n minus 1. It means n here is not 1, it should be more than 1. N can be 2, can be 3, can be 4, etc. If L is 1, n will be more than 1. And now, pay attention on this. Here, there are some formulas how we can calculate the number of electrons, the number of orbitals, etc. So on a shell, we said that on a shell we have subshells, and on subshells we have orbitals. If we would like to find how many orbitals there are on a certain shell, we use this formula, n squared. It means we take the principal quantum number, like find its square form, like n power 2, and we will find the number of orbitals. For example, if principal quantum number is 4, then the number of orbitals on this shell, on the fourth shell, will be 16. If we would like to find the number of orbitals on a subshell, we'll use the orbital quantum number. It will be 2L plus 1. For example, if L is 1, the number of orbitals here will be 3. And these are the formulas for finding the maximum number of electrons. So on an orbital, we know we have maximum 2 electrons with different spins, maximum 2. On a subshell, okay, if the number of subshells on the shell is 12 plus 1, so the number of electrons will be, number of orbitals on a subshell is 12 plus 1, so the number of electrons, if on one orbital we have 2 electrons, to find the number of orbitals on the subshell, we will multiply this formula by 2. It will be 2 times 2L plus 1. And we said that on a shell we have maximum n square orbitals. So the maximum number of electrons on a shell will be 2 times n square. Now let's practice a bit again. Here you see some quantum numbers. You have to find how many electrons can be characterized by these quantum numbers. So pause the video, try to do it by yourself, and after that we will discuss it again. Okay, let's start. In the case of A, n is 2, L is 0, ml is 0. Okay. If n is 2, it will be the second energetic level. Okay. L is 0. Again, let's see our table. If L is 0, this is S subshell. So this will be S orbital, the orbital of the S subshell. So it will be 2s. 2s. Okay. ml is 0. If L is 0, ml will always be 0. So this is 2s orbital. It means we have 2 electrons, because on one orbital, 2s subshell consists of one orbital only. So on one orbital we can have maximum 2 electrons. It means we have 2 electrons only on this orbital. Okay. And let's go to the next one. N equals 1. If n is 1, let's find what can be the value of L. L can vary from 0 to 1, right? So, not 1, but n minus 1. Look, n is 1, L will be n minus 1 or 0. If n is 1, so L can be only 0 here. If L is 0, the magnetic quantum number can be only 0. If magnetic quantum number is 0, it means this is 1. If ml, we have a certain value of ml. It means that this is only one specific orbital. If it's one specific orbital, there will be only 2 electrons. Look, this will be 1s. If L is 0, it's s orbital. 1s orbital, only one orbital. On one orbital we can have 2 electrons, so it will be, the answer will be 2 electrons. The last one. Look, and in the last case we have 4 quantum numbers. One electron is characterized by 4 quantum numbers. If we have all 4 quantum numbers are given, it means that this is only one electron, because in one atom there cannot be 2 electrons with the same quantum numbers. I mean, with all 4 same quantum numbers, like some of them can be similar, but all 4 of them cannot be the same for 2 electrons. So it means that if we have 2 quantum numbers, it is only 1 electron. We don't have the second electron with the same complex of these numbers. Well, if you have any questions, you may write me in comments. I will answer you. Try to practice, to exercise by yourself. And if you have any questions, you may contact me. And see you in the next videos. Bye.